Okay. Last class we have started the file system. This is new module, and we know that what is the till we learn the create system call. Okay, let's explore some little bit more from create system call as well as the read write some and open system calls. Okay. All right. So you know that when you make a create system call, create means that you want to. Let me turn off my video. Create system call when actually let's you create a new file, new MS Word file. Then you make a then when you press the save button, that time your MS Word software actually calls the make a system call, which is the create create function. Also, this is done by your MS Word software. Also, create system calls. This is a create. Create is a function. It's take one parameters, file name is a parameters. Once you call this function, what it will do, whatever you file actually wants to save. Let's say this is file one. You wants to create the file name is file one. Then what it will do first? It will split the file number in some fixed block size. This file block should be equal to the this when you make a save button at first, it will make your whenever you click the save button in your MS Word file, let's say your MS Word file name is file one, and then when you click the save button first time, you create function will split this file in some fixed block. This block size is equal to your SDD block size. SDD, your hard disk. You know that in your hard disk is nothing but there are several blocks. It should be always your SDD block size. Okay. Block size. So this block is equal to your SDD block size. Let's me draw in here. This is the SDD. Let me here just that it depends on also we know that in some of the most of the cases is this block size is 512 byte. Okay, this is also same. This file's block size and SDD block size is equal. This is also the 512 byte. All right, let me write some block. Get some block inside this hard disk. There is millions of block inside your SDD drives, but it depends on you on the your hard drive size. Okay, your hard drive size. If you have 2 to the power, if you have 412 GB, 512 GB, then you have total 2 to the power 30 blocks inside your SDD. Okay, inside your computers. So now let's say once you save this button, it will your MS Word software will call this create system call, and at first it will make some blocks, create some blocks to your files, and then what it will do, it will this is block number, let's say 0 1 2 3 4. It's created 4 blocks, and these 4 blocks it will store inside this hard disk, and then next this is the next step. First step it will make this block, and second step it will store this block inside this hard disk. Of hard disk blocks, it has some numbers. Okay, this is called this logical numbers. The block number inside your block number of file block number is known as the logical block number. Okay, logical block number. A block number inside your SDD hard disk is called this physical block number. You know already, this is physical block number. Physical. 。  block number. 。  . 。 . 。 . 。 . 。 . 。 . 。 . . 。 . 。 . 。 . 。 . . . . 。 . 。 . 。 . 。 . 。 . 。 。 . 。 。 . . 。 . . block number. Let's say, let me write some number. This is 5, 6, 7, 8, 9, 10, 11, and so on. Okay. Now, next step, what actually create function will do? Create function will store this file inside this hard disk. Let's say it store this 0 block in block number 5, and 1 is in here, then 2, and then 3, and then 4. Let's say this is contiguous allocation. This contiguous allocation. So each block of this this all 5 blocks should be in adjacent or contiguous location, not in that 5 is in here, let's say 6 is in here. It actually doesn't like this. If it is non-contiguous, then it can we will study more about the contiguous and non-contiguous allocation. Now let's consider this is the contiguous allocation. In contiguous allocation, each block of file should be in a contiguous location inside this hard disk as well. Okay, this inside this hard disk, so all are contiguous locations: 5, 6, 7, 8, 9. Okay, these 5 blocks, it takes these 5 blocks to store this file. And next is what your file system will do. Your file system will maintain the directory tables. You already know about this directory table. I already mentioned in our last class. It is directory tables. It has several entry. Most of the is very important entries: name, as well as the block number, location. We can see this location only, location of file, location of file, and then another attribute can be total block. We'll see this total. Let me draw it in here, another place. Let me small these things. This is SDD. Let's say this is the file directory table. So file directory table is always stored inside your SDD. This should be maintained. It depends. The number of entry depends on how many files inside your hard disk. Okay, number of entries or rows. This is called. It has this file name as well as the location, and also some other entry as well. Read, write, and I just write this some important entry, size of a file, everything, but also the total block of a file. Okay, so let's say when it save this is file 1. Let's say F1. This is F1, and then what it will do? It will make an entry for this file F1. And location, what is the location? Location is nothing but actually where zeroth number byte of this file is loaded inside this hard disk. Here is number 5 block. This is the number 5 block. This is number 5 block. In this number 5 block, 0 number. This is 0 number. This is 0 number. So 0 is loaded at number 5, block number 5. So location will be the 0th block location inside the physical inside the physical location. Physical location is 5 for 0. So 5 will be in here, and total block 1, 2, 3, 4, 5. So total block is 5. This is also important. We will learn this. There is how many blocks for this file? 1, 2, 3, 4, 5. So total block is number 5. So this is so by using from here you can see by using this starting point of this file. Starting point means the 0 files and number of this block. You can read this total file. So 5, and then you can add total 5. 5 plus 5 is from here. You can say that another 5 in this 1, 2, 3, 4, 5. So starting from this starting part, you need to go through total 5. Then you will get all of this, or all of this byte for a particular file. For a particular file. Okay, so total block number is also important, and then you have some other information: size of this file, and then read write permission that we see in our file control block. Everything should be present inside this file directory table. This is directory table. Okay, inside this directory table. Now let's see. So this is the directory table, and then uh, so each step is here. That first, when you save a file from this MS Word software. Let's say, for example, for MS Word software, it will create a it will it will make a system call, calls this create system call. It will make the create system call. At first, create system will split the file into some number of blocks. It is usually most of the cases 512 bytes. So this block size is equal to the your SDD block size. And then next step is this block will loaded inside this hard disk, and then it will make an entry to the directory table. And this is permanent. Directory table is permanent. It also stored inside the SDD block as well. Okay, because when you read this file on, or when you open this file, this time you need this directory information. Otherwise, you cannot open this file or read this file efficiently or effectively. Let's say if you want to open this file for F1, let's say it is loaded something like millions of block letters, okay, 1 million blocks later, then you need to search every blocks to figure out this file. But if you have this entry, you know this starting locations of this file, and then from this starting location and number of blocks, and from this starting location and number of blocks, you can read this file easily. So your every file system should maintain this directory table. Otherwise, you cannot do the read that operation efficient way or faster way. Okay, so you need to maintain this directory table, and it should be stored inside this hard disk as well, this directory table. So how many entry will be in directory tables? It depends on how many files inside your computers. Okay. Every file, it has information inside the directory tables. All right. Now let's see that how. So this is the logical. One thing is that this is logical block number, and inside your hard drive, this is physical block number. The block number inside the hard disk drive is called the physical block number. The block number for the file system is called the logical block number. Okay. Now let's see how you can convert to the logical block number to a physical block number. Okay. Now let's see how you can convert to figure out this logical as well as the physical block number. Okay, so for logical and physical block number, let's say you want to read some byte. Your computers means your CPU request to the byte let's say this for this file, request to the byte for this let's say 500 and 12th number byte, or let's say 10th number byte, 10th byte from this file. Okay, from this file. So so you know this block is 512 byte. So where is the 10 number byte should be in here? 10 number byte should be inside this block. This is 0 block. This is 0 number block. This is 0 number block. This is 1 number block, 2, 3, and 4 number block. So you know this block is 512 bytes. So your CPU requested the 10th byte from the file F1, wants to actually ask for 10th byte from F1, wants to read this byte, wants to read this one. So let's say 10th byte is somewhere between in this point, or also inside your SDD, it is located in this place. Okay, 10th byte, because 0 is located at block number 5. Okay, so 10th byte, how we can get this 10th byte? The 10th byte is at which block? At first, you need to measure that at which block 10th byte is available. So this is start from 0. So 0, if you start from 0 to, it will be total 512 bytes. So total 511. If you start from 0, then total 511 byte will be the block number 0, and block number to start from this 512 till 2000, 1023. Okay, and here it is block number this is one. Block number 2 will be start from 1024 till, and then so on. Every byte, every block is, this 512 byte. You just add it from the 0, so it will be stop at 512 byte will be stop at 511. Okay, so 0 till 511 bit byte will be inside this 0th number block. So how we can get this? Which 10th byte at which logical block it is present? So it is nothing but what you can do, you can make it 10 divide by total byte number is 512 byte, and just make it just 4. Then it is fine. It will give you the logical byte number. All right, let me, where it is. Okay, so if you, let's say, so 0, that will be something called 0. So you will get this 0 number logical block in here. So 0 block here. So 10th is available at 0 block. So what's it will do? From here you will get this logical block number. So now from this file directory table, you know this, where this 0 number block is available. So 0 number block is available at 5th block. So 5th block of this physical hard disk block number. So 5th block. So your operating system will pull up this all this byte from this block number 5th, and it will store inside this RAM as well, and from this RAM your operating system can supply this 10th byte to the 10th number byte to the CPU, okay, CPU. This is why actually it is done. This is how actually it is done. So now this you see in fifth block, even though it's request for this 10th number byte, only 1 byte, but I mentioned already, read date operation performs in block wise, not a byte wise. Even though it's your CPU request for this 10 number byte, but your operating system will compute this, where this 10th number byte at which logical block this 10th number byte is available. And from this logical block number, it will figure out this location of this file. And from this location of this file, it will capture the physical block number of this byte. And from this physical block number, it will take this whole block to the RAM. And if it is take this whole block to this RAM, here is 10th block is available. So from this RAM, your CPU can easily read this 10th number block. From this memory management, we already studied. Now let's see this some byte it is available. Let's say 600 by byte actually asks for your CPU, asking for the CPU. Then what's your computer will do? Operating system will figure out this, where at which logical block this 600 byte is available. So it will make this 600 divide by 512. It is nothing but 1 point something. So it is floor, so it will make a 1. So at logical number, from this logical block number 1, your 600 byte is available. So byte number 600 is available. So yeah, how it will get this convert this logical number to the physical number. Then it will go to the file directory table, where this file is available. It will search this file. F1 is available in here. From this file, it will get the location of this file. Location is nothing but nothing but the zeroth logical number, zeroth block of this logical address. Okay, logical block number. So it will add this location number 5 plus its location, its location of this 1600th logical block number, just one, and then it will get the 6. So at 6 number block you will find the where the 600 number byte is available. So 6 block will be pulled inside this hard disk, and from the here it will read the 600 byte from some places, like for example from here. Okay, so this is how your computer can actually compute the logical block number, and then from this logical block number it can figure out the physical location of a particular byte. Okay, so in a short we can say that logical block number, in short we can say this logical block number, let's see, logical block number equal to logical block number is no, sorry, logical byte number. Sorry. Logical byte number is presented the logical block plus physical block number of logical block number plus physical block number of first block or zero block. Okay, first block. First means the zeroth block. First block. So this is how you can get the logical byte number for a specific file. Okay. Okay. From here you know that why directory table is important. So when you open or create read a file, that time you need this directory table, because directory table maintain the location of the first block of your specific file, and from this first block it can get the next block also. You can, from this first block it can access the any byte for a specific file. Okay, by computing the logical block number and just simply add the location location of the first block of the specific file. Okay, do you have any confusion or any questions? How we can calculate logical and physical block number, convert the logical and then physical to get the byte. Okay. Now let's see our next item is now this is all for this create function. Now we'll search for another function called it's called this. It's known as the open function call. Okay, open function call. Let me clear some part before I start the open function call. This is another system call. There is create system call. When you create or save, when you actually save this file, it will be stored inside this hard disk, and then after that, once you save this file, then after sometimes or some days later, you may open this file. Okay, when you are trying to open this file, that time there is a let's say again, let's say it is MS Word software. You're trying to open a MS Word document. That time your MS Word software will make a open system call. It will make an open system call by using the file that you want to open. Okay, by using this the file name. Okay, by using this file name, it will make a open system call. This is also system call. System call is nothing but this function is available inside this kernel or file system module. Okay, file system is kind of very large program, and this function is reside inside your operating system, and in this function also, there is one function is called this open function. So this function is responsible to open the MS Word or any type of file. Okay. Now let's see that how open system works. So this open, when you make this open system call, what's it will do? It will to make an open system call. Actually, here it's maintain two types, two others table as well. Instead of it maintain the two tables. Let's see that what's are these two tables are. One is called the per process open file table. One is called this. One is called per process open file. Per process open file table. Another, it contains the per process. It contains two fields. One is for logical byte number to be accessed. Another field is pointer to pointer, and that is pointer. Its point. Another table is called system wide open file. Okay, that is another one pointer in here. This is pointer field. This is byte to be accessed. Let's say 8 byte. Okay, and that is another pointer. You know already pointer, and pointer is point to another table. This table name is system wide open file table. System wide open file table. These two tables is maintained by open system call, and system wide open file table maintain the name of the file, as well as location of block, location is nothing but location of zeroth block or first block of a file. Okay. Let's see, this is F1. If it is file F1, this file, so its location you know already. This is 5, so it's 5. So these two table, one is the open. Let me change my color paper. This is open file, per process open file table, as well as the system wide open file table. These two table maintain inside the RAM. Okay, RAM is inside the memory. All right. From here you can see that system wide open file contain the same entry. Not only actually there is a location of this file also. It's also take this block, total block number, one entry, all entries, particular entries, just a copy that is available, the file directory table that is copied to in here. Okay, this system wide open file table maintain the table, kind of shorter version of the directory table. You know this in directory table, it contains, it is nothing but the entry is kind of it can be thousands of entries in here. It depends on how many files inside your computers. Okay, and system wide open file maintains. At first you need to know that what is the system wide open file actually meaning. The system wide open file means that how many files are currently open inside your computers. Okay, a system wide open file is similar to the directory file, but it is shorter version of the directory. The attributes of directory tables and system wide open files are also similar. The entries of the tables are files that are currently open by different process. You know that in your process, in your computer, there are several kinds of processes available. 5 or 6 processes can concurrently run inside the computers. But every process, some process may need to open some file. So whatever this process open a file, it has an entry system-wide open file. From this name, you can know the system-wide open file, that how many files is currently open by different processes. So its entry in here. So entry is similar to the directory table. Copy the directory table. In directory table, you know, there's F1, F2, F3, F4, and F until Fn file is available. And currently you open this file F1. So F1 entry will be inside the system-wide open file. And then let's say this is opened by MS Word software, F1 table. Let's say you have another software, let's say Google Doc software. You also open this another file this by this one process. Google Doc is one process, MS Word is one process. So you open, and by using MS Word software, you open this file F1. Let's say by using this Google Doc, you open another file called, let's say, F6. So F6 will be inside in here, and then also it's all attributes. Its location, let's say 100. Possible location is 100. So all this entry will be copied in system-wide open file. So these two things are maintained inside your inside the RAM. Okay, RAM, random access memory. Now let's see how actually your system can maintain this table. Okay, per process open file. Okay, per process open file, it maintains the per process wise. Per process, every process maintain this table. Okay, table, every process maintain this table. Every process should maintain this table. It depends that when you open a file that time also, for example, let me explain it differently. There is one pointer. So let's say by using this MS Word software, you open a file F1. So and then once you open a file, so you want to access the at the beginning, you want to access the 0th byte, let's say 0th byte of this file, and it will point to the whenever this entry, this file F1 entry. And let's say your Google Doc, it's also maintained some another per process table as well. So from this name, you can know you know this is per process. This is not a per process. This is for all process system or double file, but this is the per process entry. So once you open, let's say Google Doc also maintain another same table as per. This is per process. This is logical bytes want to access, and then another is pointer maintained here. So logical byte, let's say it's currently it's 0 number byte want to access from this Google Doc, and that is point to, it's open the file number, it's called this F6. So it is point in here, its file, its points. From here, you know that when you open by using MS Word software or Google Doc, or let's say OpenOffice software, OpenOffice software, you want to open this same file as F1. So you can open a similar file by using different software. Okay, also you know this different software is also different process. So when you open same file by using another software, then when not only same file, when you open any file by using another process, actually when a process wants to open another a file, when a process try to open a file, then it will look, actually it will search that this file entry is available inside this system-wide open file or not. If it is available, then it doesn't take this entry from this directory. What it will do, it will just point this file location. You know, from here, actually every software or every process wants to try to know this logical block number, where the 0th block is available. Let's say file F1 is trying to open by OpenOffice as well as the MS Word software. Then OpenOffice will also point. OpenOffice also have this kind of per process file table. So this per process file table for OpenOffice file process table also point the this is pointer entry. This pointer also point this F1. It doesn't. They can check to the directory file directory table to collect the entry, because this for F1 information is already available inside the RAM. Okay, that's why when it saves a lots of time, because hard disk access is very time consuming. Also, this is directory table is very large table, and from this table to figure and search a entry, it is very also it is very time consuming method. So if this file is already available inside the system wide open file, just it point to this file, because from the system wide open file you want to know this first block of the or physical block number of a particular file. So from this physical block number of a particular file, and then if you maintain, so why you need to maintain this per process open file table? You know that from here, first entry is logical byte to be accessed. When you open a file, it will access from the 0th byte. Okay, this file also, let's say this is for same file it's want to open by using this is file name, sorry, logical bytes to access. Let's say I maintain LA logical byte to accessed by this process. This is for OpenOffice. Also, this also point the pointer also point the F1 file. Means that OpenOffice as well as the MS Word try open the same file, F1 file. So here also it's also try to open this and also point this F1 file as well from here. So both are wants to 0th number byte from this computer, from this hard drives. So both of them get this 0th number byte. Let's say open file OpenOffice, and so OpenOffice till read till 200 byte, and MS Word read till 100 byte. You see that this reading is kind of different. Reading is different. It's once the till 100 byte, and it's now it's access for these 200 numbers of byte. So this can be different. That's why you need to maintain this per process open file table for an individual process. If you allow allocates the CPU for OpenOffice for a little bit long time, so it can read more bytes. And if you allow the CPU for MS Word software a little bit less time, it can read till 100. So this byte number reading next, this is logical byte to be accessed. Means that it access this number byte, and this process is accessed kind of 200 numbers of byte next. So this can be different, depends on the scheduling. So that's why you need to maintain this logical byte number, per process open file table for a particular process, not a you cannot maintain it commonly for every processes. Okay, a process can wants that 200 byte, and another process can wants to currently access for the 300 byte. So it can be mismatched. That's why you need to maintain the logical per process table for a every process individually. Okay, not a single process. Also, this thing system wide open file, you can maintain the per process. You can maintain the per process. Every process commonly from here. What it will do? It is like nothing but shorter version of a logical directory table. And from this table, you want to access the logical block number. You want to access the logical block number. So it is only for this location of this logical first block or logical block number, and from this block number you can read any byte from the SDD. Okay, this is the purpose for system wide open table as the logical table as well the open function call. By using this open, actually you wants to read or write a file. Whatever you wants to read and also write is also the same thing. In our next class we'll write that how read and write function works by using the open function call. Okay. Any questions or comments today? All right. So if you do not have any questions, we are almost running out of time today. Let's start in our next class, and we'll start the how we can read and write file from a SDD. It is same as the open. If you know this or open file call, then read and write is very easy to understand. Okay. Okay. Thank you. Have a great evening.